Hello, and welcome to today's webinar featuring a practical guide to disaggregated networks where Scott Data and IP Infusion present keys to success. This webinar runs for 45 minutes, and we've reserved time for a Q&A at the end. I'm Kelly LeBlanc, Chief Marketing and Product Officer for IP Infusion based at our headquarters here in Santa Clara, California. Today, I'm joined by two very special guests, Dom Romeo from Scott Data and Vince Shuley from IP Infusion. I'd like to thank each of them for joining us and allow them to introduce themselves. Dom, hello, can you please introduce yourself and your company and briefly explain what you do and why you are qualified to speak on open networking?
Yeah, thanks for the warm intro. My name is Dominic Romeo. I'm with Scott Data. We're based out of Omaha, Nebraska. We're a Tier 3 data center co-location facility with around 60,000 square feet of raised floor space and 20 megawatts of critical power. So we're very happy about our position in today's higher density world. My background is almost 25 years in the IT service provider space, and I've done everything from operations, engineering, architecting, product and service development, and now I'm leading the technology services development effort at Scott Data as we evolve from only doing colo. We're going to add some managed services on top of it. So I've had a lot of experience building services on top of robust network and storage and virtualization platforms.
Oh, excellent. We're great to have you with us today, Dom.
My pleasure.
Vince, can you please introduce yourself and explain what you do and why you're qualified to speak on open networking?
Yeah, no problem, Kai. I'm Vince Shuley. I'm the director of our Global Technical Solutions program for our channel partners here at IP Infusion, as well as our customer engineering program, where we're starting to offer services out of that as well to help people in their journey to disaggregated networking. Before that, I started out by building networks in the military and coalition networks for U.S. European Command, living out of Germany. When I went from there, I went over to building service provider and data center networks as a consultant for a few years before I decided to make the jump to IP Infusion and continue to work in the open networking space full-time.
Excellent. Thank you, Vince. So today we have a great lineup. I'll start with the brief introduction of IP Infusion and open networking, and then Dom will share his open networking journey at Scott Data with an interactive discussion with Vince. As you know, Vince has been involved with this deployment from the beginning as well. And at the end, we've saved some time for Q&A. So please ask your questions using the Q&A button at the bottom of the screen, and we'll answer them. By the end of this webinar, you will learn how IP Infusion's OcNOS and open standards like EVPN and VXLAN are enabling Scott Data's services for GPUs, scale-out storage, and networking beyond 100 gigabits per second. And Dom has prepared an update that's hot off the press that we've saved for the end. So let's get started. So in this webinar, we'll be speaking about Scott Data's use of IP Infusion's disaggregated networking solution called OcNOS. OcNOS is a network operating system which provides a common software platform that runs on your choice of hardware, including open networking hardware from EdgeCore, UPspace, Celestica, and more. And the value of network disaggregation is freedom of choice without vendor lock-in, reduced CapEx and OpEx thanks to optimized software running on white box hardware, and reduce lead times versus incumbents in many cases. A little bit more about OcNOS. So OcNOS is a mature networking operating system for wireline, wireless, and data center networks. We're able to replace incumbents such as Cisco, Juniper, and Arista with our complete feature set, our industry standard CLI, and also our new GUI-based management product called IP Maestro, which delivers point-and-click OcNOS networking. So in addition to your choice of white box switches and routers, you also have your choice of optics. Here you can see that OcNOS provides end-to-end solutions with the same software. Our OcNOS use cases include mobile backhaul and access, aggregation and metro networks, routed optical networks, and data center networks. So you can see the scale of our solution here starts at 32 gigabits per second and scales all the way up to 14.4 terabits per second with the same software on open networking hardware. And customers can select their choice of optics, including 400 gig ZR0 plus optics. Now, before we learn about Dom's open networking journey, Scott Data, I would like to introduce the use case that we're speaking about today. So I'm pleased to introduce Scott Data, a nationally recognized data center facility based in Omaha, Nebraska, and one of only 14 multi-tenant data center facilities in the nation to receive Tier 3 certification in both design and facility from Uptime Institute. Scott Data has chosen OcNOS and open networking strategies to upgrade their network and to aid future growth. And as a technical innovator and leader in its market, Scott Data selected open networking as the logical evolution as they expand their network services, which we're going to learn a lot about today. So without further ado, let's have Dom start the discussion on his open networking journey with an overview on his current deployment.
Thanks, Kelly.
Over to you, Dom.
I'm excited to talk about it. So we're also pretty lucky because Vince helped us on some of our initial steps of this journey. Scott Data, when I came on board about 2 years ago, we had an opportunity to look at our existing infrastructure and see how we needed to reform things to support our vision of deploying more managed services. And as luck and timing would have it, we had some Cisco gear that was coming end of life. So we were in a position where we needed to reevaluate hardware. And anytime you go and look at that stack, you always want to be requirements and use case driven to make sure that you're finding the solution that meets your needs now and what you've got mapped out in the future. So a lot of our needs and requirements revolved around layer 2. We have a fairly large data center footprint wise. Most of our customers bring their own network. However, some do rely on us for their east-west networking, and almost all of them use us for their north-south networking to get out to the internet or other service providers. So we had some fairly traditional layer 2 use cases from a delivery perspective for customer handoffs in the data center. In the past, we'd been a multi-10 gig backbone, so we wanted to step into something that was had more room for growth for us. So 100 gig was part of the requirements package. The other part of our unique footprint here in Omaha is our 3-story building. So we have a technology transfer and innovation center right next to the data center, and we wanted the leaf spine architecture to also be able to handle some connectivity in this building. The use case there that we envisioned were customers occupying data center while also having people in cubes or offices or conference rooms over here that would want some dedicated high bandwidth layer 2 connectivity between those two buildings for different uses, build outs, retrofits, upgrades, things like that. So we also have internet customers in the 3-story building over here as well. So when we sat down and looked at this, we talked about all those use cases and started surveying the marketplace. And we started with the traditional vendors. We've been a Cisco shop. We've had a lot of Cisco gear deployed, so that was a first place that we checked. I had come with some background from Arista, and I really love the quality of the software of EOS, and there's some interesting hardware out there from Arista, the way that they're making use of commodity chipsets. We also liked what Juniper is doing, especially with Mist and everything that they're adopting with their new EVPN fabric. And we looked at a couple other traditional vendors as well. And then we started looking at, okay, is it the right time? Is it possible for us to try to use open standards like EVPN and VXLAN, but also go the next step and do disaggregation, where we buy the network software separate from the network hardware and potentially open up a world of choices for us. So this was about 2 years ago, right when I first came on board. We started looking at this journey. The other thing that was happening at that time is we were just recovering, or starting to barely recover from the supply chain crunch that I'm sure most of us on this call can relate to. And what we found is that we were facing 200 to 300 business day lead times for some of the traditional vendors, where the edge core UV space gear was available in a matter of 4 to 8 weeks, and even less. Actually, after we placed the PO, we had a lot of that gear with the OS already loaded on our doorstep in a matter of 2 or 3 weeks. So we were hugely impressed with that aspect and being able to mitigate the supply chain challenges. So yeah, that's I probably talked a lot. I'd love for Vince to weigh in because he has some unique insights in that, since he was involved in our requirement scoping process.
Yeah, so it's been a long time, and at the time I was actually a consultant for IP Architects, the previous firm I was working for, and still remember when Scott Data Center called in and I was talking to Dom, and you know it was like, okay, well, what are you trying to do? And I've like I said, I started in the DoD. At DoD, we used all the big vendors, and it's like, so I was familiar with all those names. He just came out. Then he's like, but I really want to start looking at the disaggregated approach. And I was like, well, the one thing that I really learned with disaggregation, when I came out of the DoD and I got a was you can usually deliver the same service that's needed with the disaggregated options. So especially with OcNOS, we have a lot of features, and a good design is going to be the simplest one to meet the business requirements. So we started going through what are those requirements, and I have this idea in the data center, any service, any port, right? So no matter what it is, it can deliver it. So if I have a well-designed fabric, then I can deliver any service on any port. And Dom was like, yeah, that's the same thing we're going after. And then he started to list off all these different uh environments that he had. So he had that offsite uh set up, he had the technology center he was talking about, he had his data center users. So it was okay, so how do we solve all of that? So it's like, well, we can't go into the campus space because there's not the campus feature set, but we can bring the fabric over there and replace the distribution nodes. But then by doing that, we can also get rid of the chassis, but we can bring EVPN fabric, the multi-tenancy there. So if you want to do the cross connect back into the data center, you can do that, or you can go straight out to the internet for the services that you need, and you can hang those enterprise style switches below that just as access switches, multi-home uplink, and you get that resiliency that you're looking for. And then we started to evaluate the different options, right? So everybody really likes the idea of free and open source, right? So I still remember I asked Dom, I said, okay, you want to go free open source? Do you have a developer on staff? The costs of free open source start to add up once you bring in all the human capital that goes into it to be able to maintain it. So it's like, okay, so we don't want to go something that's completely open source. We want to have commercial support. Okay, we need to have layer 2 functionality with EVPN VXLAN. And we couldn't have seen the GPU service that they're going to start offering, but being able to add into the same environment switches with deep buffers based off DNX without having to change the OS. So you can have leaves with XGS for your generic workloads. You could have leaves that have deep buffers or high route scale for internet routing, or where you need more capability, or DCIs. So it became that whole ease of operations across the entirety of the data center. I think that's really where we looked at that, we took it, and then we said, okay, how can we take the cost savings and roll that into other aspects of Dom's business and Scott Data Center's business, and say, okay, now we can offer these additional services. We can offer these additional capabilities. We can put our efforts into these places. So, I'll let how we went next back over to Dom.
Yeah, thanks, Vince. So your two things I want to underscore that you said, the ability for us to leave our current access layer intact was a very nice design concept, and the team on my side loved it a lot, because we have a lot of 3650s and PoE devices that we didn't want to touch. And once we understood the concept of being able to uplink those, have the VLANs translated into VNIs, and pass the traffic that we needed to with increased redundancy, still maintaining our stack wise where we need to, but also connect to those leaf pairs for EVPN active multi-homing. that really unlocked a lot for us. We could just focus on that core and that distro layer, like you mentioned, and leave the access layer in place. And that cut out so much time and effort for us. We didn't have to go think about moving thousands of Cat6 cables to different ports, and we just left that layer in place and bought some additional hardware redundancy for that piece of the network. The other nice thing was we had a Nexus 9000s as kind of the core of that layer 2 network, and those are co-located over in the data center. And you can see on the internal leaf 1 and 2 on this diagram where that is represented by the VPC ability. So we successfully, quite easily, interconnected an LACP EVPN connection over into a VPC connection on the Nexus 9K. So the layer 2 integration was, as we thought, seamless. We also did some hedging, right? One of the things that we did before we went down this path of disaggregation is we brought the equipment in-house and labbed up a few of our key scenarios. And that made a lot of difference. That raised the confidence interval on our team that's supporting this. It showed us that we could do it. It also showed how convenient it was to buy these devices from IP Infusion. They came with OcNOS pre-installed. Not that ONI is hard to deal with. There's plenty of documentation about installing OcNOS from the thumb drive or a TFTP server or an HTTP server. So dealing with ONI and installing it ourselves was fine, but it made it more similar to the experience that our team was used to, where you buy the switch or the router from the vendor, it arrives on site, you can go deploy it. So we did that in our lab, and it really paid a lot of dividends. We also introduced some concepts by having lab gear that replicated production that we brought forward. We'll talk about later in the presentation. So yeah, that was one thing I want to underscore. And the other one is just the flexibility, the design concepts that came out of this with having the underlay with the EVPN overlay really unlocked a lot of problems that we faced from a spanning tree perspective. The quote that I love repeating is, "Overlay is the only way." It's really true for us. There's some folks out there that might want to keep it simple and want to just do layer 2 or MC lag. But the beautiful thing about us with an overlay is these are all industry standards that have been around for almost 10 years now, especially when you talk about EVPN and VXLAN. There's RFCs and tons of documentation from various vendors. So it's really a multi-vendor supported solution. So the great thing for us was finding the disaggregation solution with OcNOS and EdgeCore UPspace Celestica, but also knowing that we could run open networking protocols and standards that met our exact use cases. Those things all coming together at the same time really excited our team and allowed us to make this decision, even in a service provider environment, even in a data center environment.
Oh, that's a great setup, Dom. Thank you. And I want to remind everyone, if you have questions as we're going along, please enter them in the Q&A button at the bottom of your screen. I think after this wonderful setup, it's a great time for us to start our panel discussion between Dom and Vince. And so, Dom, you've been talking about your experience transitioning to open networking. A lot of our audience is either in the process of this or considering it. So I'd like to talk to you a little bit about, what was your experience? Anything that our audience can benefit from knowing on your experience in the transition?
Yeah, so I think one of the first things was, like I mentioned before, raising the confidence interval of our team. They were very experienced supporting Cisco, especially with VPC and StackWise. So getting them to think about supporting other vendors, put OcNOS off to the side. Even switching to Arista or switching to Juniper was a big mind shift. And we didn't want to just make it for a technology decision. We didn't want to make it for a financial decision. We wanted our IT team and our operational folks that support this environment to have some say and some stake at the table of which solution we went with. So that was another reason that the lab was very important. They could put their hands on the gear. We could simulate failure scenarios. We could simulate, taking a device out of production, putting a replacement in. And that was so huge. That was a very key lesson learned for us, was making the lab available, testing your use cases before you go to production, and raising the confidence of your engineering and operations folks so that they're as excited as I was about deploying a disaggregated based solution. The other thing for us was, we knew we had to make some investments in education and upskilling, even just going across to a different vendor. So one of the fundamental pieces of calculus we applied to that equation was, well, if we're going to invest in our brain space, we have a lot of services we're trying to deploy at the same time. We're trying to, it's funny because we're an established business with the data center, but we're also very entrepreneurial and we're very startup mode with our services. So as a startup, you always have to recognize, what's my time value of money, my time spent, my time to revenue, all those things factored into how fast can we get on this playing field with this new disaggregated network. And we actually saw a shorter time to revenue because of the supply chain crunch. And we saw a shorter time to revenue because the OcNOS CLI and programmatic interfaces were so much like the iOS that we were accustomed to. But the real thing that really set something home with our folks was that they could upskill themselves into open protocols. Hey, if I'm going to go learn something new like MC-Lag from Arista, why wouldn't I just try to go learn EVPN and have a protocol that is now an open standard that can apply to any vendor? Now I'm moving away from this vendor-specific solution to spanning tree loops on my network, and we don't have to think about things in terms of what can StackWise support, what can VPC support, what can MC-Lag support. Now we can go to open standards, look at the RFCs, understand how these things should work, have a lot of daylight shed on how these things should work and the ability to interop with other vendors. That was a big aha moment for us. Like, hey, if we're going to go invest this time, let's invest it in something that we think is more future looking, more innovative.
I love your quote. Overlay is the only way. Let's deep dive a little bit more on OcNOS and open standards like EVPN and VXLAN, how it's enabling your services, because I think that's something that this audience can really benefit from.
Yeah, so I think oh, sorry, Vince, you want to weigh in? I've been talking a lot. You have some thoughts. I'm sure.
Go ahead, Vince.
It goes back to that idea that I said earlier, right? Any service, any port, right? So
yes,
in order to hit that, that's what you were trying to do, and you might have. I think we had this conversation with we were talking about this. You might have some purists out there that say, "Oh, that's a bad idea," or this. Ultimately, for the objectives of your business, that was the right move, right? Especially with the way that everything was laid out. So in order to do that, you need the multi-tenancy, and the best way to do multi-tenancy is to provide an overlay. And the overlaid networking that we went with was EVPN because it has a huge amount of benefits. You can use it with a VXLAN data plane. If you want to go to DCI, you can go interwork it into the MPLS to bring it into your WAN. If you run data center, then WAN network, then another data center. So then you can also go and you move your MAC learning all up into BGP, which already scales, to internet routing scale. So you're solving a ton of challenges there along the way of being able to operate your network efficiently and in a manner that allows you to deliver those services.
I totally agree. You hit the nail on the head. Any service, any port. I have worked with some architects in my past lives that also share that same sentiment. I have a special place in my heart for network nerding. I would consider myself a network nerd, and that concept is really it's valuable. It's valuable from time to delivery, but it's also valuable because maintaining different networks that are dedicated to different silos of your infrastructure is a losing effort. You're going to lose time, you're going to lose money, you're going to lose scalability. If you have an EVPN fabric that's set up properly and you know your use cases, you really have that, maybe one layer of spines or some super spines. So you have a horizontal and you have the vertical scalability. So one of the tricks that we did is we wanted to have a 400 gig spine, but we knew that some of the devices that we were looking at just weren't quite ready for it. But we had talked about roadmap with IP Infusion, and we knew it was coming. So when we deployed our 100 gig spines, we made them a class of device that could also do VXLAN. So instead of just pushing the packets in BGP, we thought, okay, if we're going to decommission these devices at some point, we'll put them down at the access layer, the leaf layer, and then we'll replace them with some packet pushers that can handle the spine layer. And that level of flexibility with the hardware and the planning, it's just so much harder to find on the vendor side. The vendors have unlimited lists of SKUs and devices that they want to sell you, right? And then it puts you on a treadmill. It puts you in a place where the vendor might sell you the solution, and then 3 years down the road or 4 years down the road, they switch tactics on that device. Maybe they declare that end of that device life. Maybe they declare that as something that they split into two different device product categories. You're really beholden to the vendor's plan for what they want to do with your network, right? And when you go disaggregated and when you go open standards, you take control of your network back. You take control of the future and your planning of your hardware and your software on your network. That was, we didn't really think about it at the time, but that was what we now see. Like, we're basically building a 10-year network here because we can dictate our own hardware replacement cycle. We can dictate our own software. If we want to run other software besides IP Infusion, we can. We're actually making plans to use it in more places on our WAN and at our internet edge. But if we wanted to pick some vendor that maybe had a slightly better solution for one of those use cases, because we're using open standards, we can do that with a high degree of confidence.
And I might be jumping a little ahead here on the conversation, but you hit something that's really interesting. And when you look at, you made the decision to bring the Trident 3 based devices as the spine layer, which conventional logic would say, oh, it's a spine, it has to be a tomahawk. That's been what's been driven down everybody's throat, and it's like, oh, you want a spine, it's tomahawk. And we were like, okay, well, I'm gonna have a lab, which is my warm spares or hot spares, I should say, since it's a complete replica. Then I took that um so I can move those in. If a device fails, I already have it ready to go. I can move it. And he said, okay, when growth comes and these new platforms become available, now I can upgrade my spine layer to a 400 gig device. I can move my old spine down into my leaf. And now there's still some leaf, some time left on that before you have to go and make the next set of upgrades into, 400 gig leaf, at which point you'll probably do the same thing of moving from 400 gig or put an 800 gig as the spine, then 400 gig down to the leaf, and now you can start to really maximize your equipment lifespan and life cycle based off what's available.
Yeah, or those 800 gig devices become your super spines, and now you can actually go out and have 400 gig based pods wherever we need it as we grow our network. So Vince, you might, I mean, I look back at the diagram that we just saw, and I have to laugh a little bit because Vince helped us through a couple iterations of that diagram. And even since that diagram we've been using as a talking point has shifted and evolved. But I think it's important for folks to understand the scale that we're operating at now. We are not a cloud data center. We have cloud services, but we are not an Azure or an Amazon data center. We don't have thousands of leaf pairs. We have about 18 leaf devices, and we have around 1,500 routes. We just today crossed 1,500 prefixes in our EVPN table. We anticipate doubling that by the end of the year, and we'll probably have even more growth as we have more customers use our devices as their top of rack or end of row switching and routing platforms. So just want to give folks a sense of scale. I think it's a huge challenge for some folks when they start reading about EVPN and data center network fabrics, because there's a lot of vigorous, healthy debate about, should I use IBGP, EBGP, is ISIS going to scale well enough? We made a lot of decisions based on knowing what our level of scale would be now and would be in 4 or 5 years in the future. It was hard to tell because we're growing a new services business, and we wanted to support scalability with a little bit with fewer problems. But in order to do that, you might overcomplicate the network today. And I have to say the simplicity of the design that we came up with was one of the reasons that the team was eager to support it. Using ISIS for the underlay and the loopback routing is great. I mean, this is actually the first time I've ever deployed ISIS in production. And I have to say it was much easier than OSPF or other IGPs I have in the past, because it was very well suited for our use case. Vince helped out a lot with some interesting, templated configs for that. The other nice thing is we just stuck with one AS for the whole overlay for all EVPN, and we didn't have to get into this debate about using IBGP or EBGP for that part of the network. And that simplicity has allowed us to quickly wrap our arms around the management of the network, so that time to operational efficiency was reduced. even with going with traditional vendors that give you a validated design and a run book, I still think we got there really fast compared to those scenarios that I have executed with other traditional vendors. And a lot of it comes down to just the simplicity that these open standards bring. They're well-worn, well-used designs. It's just a matter of picking the right information and putting it all together the right way, and letting the team have ownership of that. But yeah, the design that we came up with it fit our use case. That was the key thing for me, and we've felt so efficient, and we felt so well matched by it. We're tackling services, as Kelly alluded to. We're tackling services now that we didn't even have in mind a year ago when we started to really go down the path with OcNOS. Our network has only been in production for about 3-4 months now. We started in December of last year, but we've already moved many of our internet services. We've already started churning up storage services, and I'm not talking about like a little bit of storage. We're talking about petabytes of storage with hundreds of gigabits per second of throughput. So we're very impressed with where the network has already taken us.
And with all this that you're working on, Dom, I think support is really important. And I want to touch on this a little bit because it's a conversation that comes up in every discussion we have. How do we support? How does it work with open networking and support? So perhaps share a little bit about your journey in working with support here.
We love IPI TAC. But as a matter of fact, we just had to open a ticket with them yesterday. And they're, as we experienced when we were doing our lab and our proof of concept, I think this is our 3rd or 4th ticket we've opened with IPI TAC, and it's always been a good support experience. Our team feels empowered to support it. We have our documentation sets that we use. We have our OneNote, and we have our official documentation, and I think we did a good job of templating it. We're taking a crawl, walk, run approach with our network and how we manage it. We knew we wanted to get to net DevOps and orchestrate the network. We're working towards that. But day one, we built the network with templated configs and with some Python scripts. And eventually, our next iteration is to go to Ansible. We're actually looking at IP Maestro from IP Infusion and how we can use that potentially as well. But we're a little lower on the dev scale of net DevOps. We have more engineering folks than development folks. So we are playing to our strengths, not our weaknesses, right? We that was probably one of the other key things that we figured out in the support side of this is take what you already do well and try to make that work for you with this new network and the new design.
Right. And with all, yes, please, Vince.
When I was going back, and I go back to my consulting days, when I remember the first thing that one of the things Dom asked was like, on open networking, is there support? And I was like, yeah, why wouldn't there be? I was like, there's a TAC, you can call in, you can get 24/7 support. There's actual real support structures. So I think there's organizations, there's resellers, value-added resellers, systems integrators that are really familiar with those open and disaggregated approaches that can go not only so you have TAC support, but you also have experts that are from being able to go deploy and support. So just a couple of like the guys at IP Architects where I used to work, or you have Stordis in Europe. You have all these organizations that are really well put together and able to integrate and be systems integrators and provide that guidance. And then if you need the ripcord, as I like to say, you can call into TAC and say, okay, I need help. It doesn't look like it's doing what it does, and you can work through it. So you get that kind of traditional feel. It's a myth that there's no support in open networking. It's there. There's plenty of people that do it and provide it.
Well, it's a myth, but it's real depending on which part of open networking you go do, right? One of the reason that I had that question that we posed to Vince was we were looking at, oh, well, we could go buy a Broadcom chipset, and what would we run on top of it? Oh, maybe we'll go do Sonic. Well, then when you go down that path, back when we did, you realize that you have to download the source file and build it yourself. And like I mentioned before, we're not a development shop. We didn't have CI/CD pipelining tools. We didn't have a build environment for our software. We're used to downloading binaries and installing them. That's what we do. So thinking about building your own software from source and then deploying it was a whole thing that was, again, beyond our comfort level. So when Vince helped to expand our vision for what disaggregated networking truly means, and that there were vendors with supported software that had very similar hardware compatibility lists, that was a game changer for us.
Yeah, that's a great point, because there's hidden costs. And thank you for bringing out the discussion on this. It really leads to open networking's promise of CapEx and OpEx savings. You've touched on this a little bit, as this was key. Savings that you were able to put on one side of the business, it allowed you to expand on another side of the business. So Dom, maybe a little bit more on the CapEx and OpEx savings.
Yeah, we were fortunate. We have a strong organization behind us that is a great capital partner, and we did not have to worry about our budget. If we wanted to go buy Arista and make the quote unquote the right decision to have the most robust network, they were going to support us with that capital. But as we started looking, so we basically down selected from all the traditional vendors down to Arista, and we down selected from all the disaggregated stuff down to IP Infusion, and we put them, I don't want to say head to head, because we never really did an Arista hardware POC. We did a virtual POC with them with some use cases, which was great, by the way. The AVDs and the education system in Arista they're very nice, very accommodating to us, and I have nothing but great things to say about EOS. I'm an EOS fan. But the flexibility and the time to delivery were all huge issues for us. So even if we wanted to spend, let's just call it $1 million with Arista, it might have taken 12 months to get here, where we could spend a fraction of that amount with IP Infusion, and we could get the gear in 4 weeks. So the cost savings from a CapEx perspective was evident out of the gate. It was, we were a fraction of the number for our initial OcNOS CapEx spend, including the hardware. But then we started really looking at the total cost of ownership, right? What does it look like on day 2? What does it look like on year 5? And we started to understand something, that 1 year of hardware and software support with a 24/7, with a coverage with a 4-hour response window, paying for that for 1 year from some of the traditional vendors was enough to buy a piece of EdgeCore or UFI space hardware. So when you think about it in those terms, we started to understand something. Maybe we are very well served by this disaggregation. We will just buy the software support and have our friends at IP Infusion, have our back from the software perspective, and maybe we'll self-insure our own hardware. We'll spend a little more capital up front, and we'll have extra pieces of hardware that match the gear that we've deployed. But now we don't have to pay for hardware support. We'll basically do our own hardware support. And if this opened up some really interesting things for us. We started to think about our network more like developers think about their application stack. We were treating our network devices now as cattle instead of pets. If something goes wrong with one of our OcNOS routers or switches, we're just going to go in, unplug it, plug in the hardware replacement that's hot in the lab, as Vince mentioned, and download the config from our software control from our source of truth and move on with our lives. We will take that bad device or that suspect device, we'll go put it on the bench in the lab, and we'll troubleshoot it at our leisure. We have way too many things going on for us to spend 4 hours at 2 a.m. on a Saturday troubleshooting why an SFP plus went down or why we have link flapping. We just remove that problem from the equation and we move on with our day-to-day life, because we are doing our own on-site hardware spares at a fraction of what it would cost us to have a 4-hour response time from a hardware vendor. We can have an instantaneous response time. Oh, and by the way, we know this hardware is good because it's hot in our lab. We don't have to worry about a device shipping across the country. Maybe it's jostled around on the FedEx truck and the power supply breaks loose or a chip gets damaged. All of that is off the table. Now we really have a minute level response time as opposed to an hours or days level response time for hardware replacement.
Wow, that's a really powerful story. In fact, with this panel discussion has been so good. We have 5 minutes left and we haven't even gotten to what's hot off the press. So I want to make sure we have enough time to share this. So Dom, you had been talking about GPUs as a service, scale out storage, networking beyond 100 gigabits per second. Let's show a little bit of what do you have cooking? Let's talk about it.
So this is our one more thing for the presentation today. We appreciate you guys being interested in this topic and giving us your time. So we wanted to show you something that from my perspective, from my nerd love perspective, this is really cool stuff. We just landed 6 NVIDIA DGX boxes fully populated with H100s. And for their storage and their data networking, we're connecting them to our IP Infusion based fabric. So we're using a combination of edge core devices here in this picture. You can see the, I believe those are the 7726s from edge core, and then the DS1000 from Celestica. So the DS1000 is for the IPMI and host management copper ports. And then we've got 100 gig going to multi-mode fibers that go plug into the NVIDIA devices. And when Kelly says hot off the presses, these pictures were taken this morning. We just fired these devices up yesterday, and we plan to put them through the stress testing today. This one cabinet is a bit of a unique situation in IT right now. We have some really good partners helping us with this. I'm going to give them a shout out. We have Worldwide Technology Group, we have NVIDIA, and we have IP Infusion's been helping us along the way. We also have some help from our friends at Apollo, which is an MLOps platform, ProLego, and some other friends that are helping us. The other piece of this is storage. We have Vast Data is our storage platform, and they've all been helping us. About a year ago, less than a year ago, we decided we want to go down this path of GPU as a service, and here we are about 10 months later implementing this design. So we went with a 60 kW rack, which is fairly unheard of for DGXs. So you can see there's 6 DGXs in one rack there, and we're gonna generate some heat later today. We're gonna turn those CPUs into BTUs.
Wow, this is a lot of fun. So, when you have started your network and now you're expanding it, going into next generation data center, any lessons learned you want to share with the audience and how all of this has been going?
Yeah, that could probably be another 45-minute talk, but I think if I were to try to narrow it down, I think the flexibility of disaggregation is our key takeaway. The ability to scale, there's so many things that all converged, right? The CLO topology, the flexibility of the hardware abstraction layer of what Open Compute's been doing for our industry, providing that ONI layer, what IP Infusion has been doing. The part of the research for us with IP Infusion was that they have a strong intellectual property and history of routing protocols. So it wasn't just about making EVPN work in the data center in layer 2. We knew we could take them to do BGP and MPLS, segment routing, all the things that we eventually want to do with our wider area network. So the key takeaway is that flexibility. There's really something special about all these design choices that we've made, all these practices that the industry has been learning to make best practices over the last probably 5 or 6 years. I feel like now is such a strong time for disaggregation, open networking standards, and these cool new technologies and services, and the way that we're having to scale the services inside of our data center at a way we've never seen in the past. These GPU boxes, they are beasts. And to feed the beast, we have to send them gigabytes per second, terabytes per second of data and their number crunching ability. So the only way to do that is with a network that scales. So we appreciate that flexibility that IP Infusion and OcNOS gives us when it comes to scaling the different pieces of our network.
And how about from your perspective, Vince?
So it just goes back to I'm really excited to see where this went and where it's going. I'm a little biased now since right I helped build it, and now I joined the routing and switching vendor helping deploy it. So I'm really excited about the ability to continue to add those services, scale it out, scale up, and then continue to do that, right? I mean, it's all about that flexibility, right? Even when you start to add, and when Scott Data Center adds a second data center and they need to stretch across the WAN, right? They can bring a DNX platform into the fabric, bring that so it's part of the extension, and then move across their WAN seamlessly to be able to go and scale out without having to learn a whole bunch of new technologies, new vendors, new protocols. It'll be a seamless effort for them. So continue to be able to bring in those, more GPUs. I want, hopefully keep bringing in more racks. You get the GPU as a service up and running quickly, and excited to see it.
Okay, great. And we're out of time. I see we've been addressing questions in the chat. So I do want to leave on the one last piece of information that I think can really help the audience from Dom. So Dom, can you tell us what was the one key criteria that led you to select IP Infusion and open networking?
Oh, there were a couple, but one of the key ones was that I mentioned before, that there's a pedigree at IP Infusion. It's not a company that just came around in the last couple of years. There's, the history there with Zebra and ZebOS and Quagga gave us some real confidence. The fact that IP Infusion helps other network vendors with their stack was really interesting to us. And the fact that now there's such a big push for OcNOS, and the capabilities of OcNOS are, I haven't seen any other disaggregated vendor that has the same level of routing and data center fabric capabilities, right? And we don't even touch the RON stuff that you guys also do. So we're excited. I think one of the key things, if I can get you just one, we're looking forward to the day when we can have one back to Pat. We would love to have one network operating system across all of the different use cases in our network. We're down to 3 right now. So I think we can eventually get to 1 as we start to address other parts of our network, beyond the data center fabric, as we start to get to our gateway routers, and as we start to get to some of our wide area stuff. We have a high degree of confidence that OcNOS can tackle all those use cases for us.
Oh, thank you, Dom. And I think that's a great way to end because we're out of time. And I really appreciate this discussion. I want to thank everyone for joining our webinar, and special thanks to our special guests, Dom and Vince, for joining us today. And we look forward to seeing everyone soon. Until next time, thank you.
Thank you.
Thanks.